Hello, my name is Francisco Benitez. I am developing a product prototype for analytic on projection for fixtures-less vision-guided pick-and-place. So this product prototype is very important in the manufacturing field. So what do we have? So currently when you do an automation manufacturing cell, if you don't implement a camera or an AI system, you depend on fixtures or the mechanical systems to be perfect. That's something that usually doesn't happen, and if it does, it just works momentarily, and with time they will become to be a problem. So when the robot starts to detect that the position of the fixture is different, you will have to manually invest time and money for the fixtures and to reteach the positions of the robot. So this is not convenient for a massive production line. As you know, this can generate millions of costs and also can generate dead time in production. So the proposal that we're implementing is algorithm vision guided setup and simulation. What does this mean basically? So we're trying to create a virtual environment that will adapt to the automation cell that we're trying to implement. And from there, we will add the robot, the gripper, and our products. So from those products, we will make synthetic images that we will generate different models and different positions so that vision model can learn that. So it can learn different positions, different angles, and then from there, we will do analytic on projection. So basically, we're trying to translate the coordinates of the camera to coordinates that the robot can interpret, and then it can do the feedback. So this is very important because when we take a picture for the camera is in pixels. So we need to translate that, and also the coordinates of the robots are different from the camera to so it can be interpreted in the robot and also not be in the base frame, but because the robot has a gripper, it needs to be in the tool center point, which is our TCP. And when the camera sends that data, it needs to be interpreted in the robot millimeters. So this is something that we can do in the virtual cell with AI. So right now we're going to check a demonstration. It's a very simple demonstration that I have. So right now, here's the robot. What I'm doing is taking a picture in my virtual environment. And what the robot is doing is going to that place, picking it, and then placing it. So as we can see, it's a very simple pick and place in this situation. We had some error in the gripper. If we have a better gripper, it can be less. And also right now I am using a VGA camera. So that's a low resolution camera. And if we would like more precision, we can get a more resolution camera. So we can improve that error. So this is the demonstration for the robotic with the vision. And here are the results. So for the training, we use YOLO model. And also we use the AngelNet model. So the YOLO model, we're using it to detect the XY position of the product, and the AngelNet, since the angle is very critical for our inspection and our AI compensation, it was necessary because otherwise the angle will not work. So this is very important. We need to do the YOLO model and then the AngelNet model to get precise XY and angle for a robot. From there, we made 1,000 virtual tests. As I mentioned, we use VGA camera, which is the cheapest on the market. And from that, we got 95% success rate. So this is very important because we are using one of the cheapest components in the market, and we got very successful trials. Also, as you can see, we have a 2 millimeter error. And this is also because of the camera capability. And we can improve this by implementing a more higher resolution camera or trying to, advance this prototype to make it an end product with 3D models, which is the case. Also, here we have the degrees of the aerodynamic mistakes. This was the most critical. If the degree was a little off, it would not pick it. So this was very important for the test results. But as you can see, we get very favorable test results. And basically what makes this possible is the virtual environment that we're working on. So this is the model, this is the way we're going to work through. We can have different cameras, different robots, different grippers, but it's going to be the same setup. So the vision for the end product would be for me, is to implement a 3D camera so we can compensate all the 6 axes of the robot. Then develop this on a more bigger environment that will be ROS2 for the robot. And then we can do a simple reinforcement learning model at the end to make those final fixes, so we do all the work on the AI model, and then when we build the cell, we just need to add a system of rewards when the robot picks it correctly and places correctly, so that reinforcement learning can improve the AI system. So this is the project, this is the prototype that I'm making, and I would like for us to invest more time and more money on this type of implementations because I know that benefiting can be translated for a lot of money in manufacturing companies. Thank you for your time.